Okay, so now what we're going to do is we are going to learn about solving absolute value inequalities. So I want everybody to turn to page 32 in your chapter 6B packet. Okay, so on page 32 in your 6B packet, give you time to get it. It starts out by saying solve the inequality, graph your solution. And A is the absolute value of x is less than or equal to 9. Now, because this is absolute value, we know that we're going to have two equations. Either x is less than or equal to 9, less than, so it's an and, x is flip the sign greater than or equal to -9. Okay, so you learned that last class in that short video that I gave you. Now, because this was less than, we knew that once the absolute value sign is isolated and it's an inequality, if it's a less than inequality, it's going to result in a compound and inequality. And the reason is, if you think about numbers whose absolute value are less than or equal to 9, they would be greater or equal to -9, but less than +9. So it's everything in between. So a less than inequality is always going to look like an and inequality. Now let's look at B. Suppose B says the absolute value of x is greater or equal to 9. So this is greater. So that means this is going to be a compound inequality connected with or. So you copy the first one, just as you see. For the second one, change the direction of the sign, of the inequality sign, and make this negative. So this says x is greater than or equal to 9, or x is less than or equal to -9. And when we graph this, it's either going that way. I have to fill it in. Or it's going this way. And that's your classic or inequality. And when we think about it, the absolute value is greater than 9. So it means any number, even though -9 is not greater than 9 and -10 is not greater than 9, when you take the absolute value of those numbers, they are. So anything to the left of -9 and anything to the right of +9. Okay, so now let's look at the rule that it gives us on page 32. And it says the inequality ax plus b is less than c, where c is greater than 0, is equivalent to the compound inequality. So we have ax plus b is less than c. When that happens, either ax plus b is less than c, less than, and ax plus b, flip the sign, make that negative. Okay? And the other rule says if you have ax plus b, absolute value is greater than c, then either ax plus b is greater than c, or ax plus b, flip the direction of the sign, make that negative. Okay, so the key to this is remembering the simple phrase is less than greater. Okay, so let's turn the page and do an example. So on page 33, it asks us to graph 2x minus 7 is less than 9. So right away, I write less than. So I know this is going to break into two things. Either 2x minus 7 is less than 9 and 2x minus 7, flip the sign, make this negative. So this becomes 2x is less than 16 and 2x is greater than negative 2. This becomes x is greater than negative 1, x is less than 8. So it's greater than negative 1, but less than 8. And it's a classic and looking inequality. Okay? So now let's try example 3 on page 33. We have the absolute value of x plus 8 minus 4 is greater than or equal to 2. So this is greater. But actually, I shouldn't have written that because I shouldn't make that assumption until I isolate the absolute value sign. So first, I'm going to add 4 to both sides. Now I can say it's greater than 6. Okay, so now I can say this is going to be connected by or. I write x plus 8 greater than or equal to 6, or x plus 8, change the direction of the sign, make that negative. This becomes x is greater than or equal to negative 2, or x is less than or equal to negative 14. So when I graph this, it looks like your classic or. That direction, and negative 2, that direction. Okay, so now I want everybody to turn to page 34 and stop the video and try to do examples 1, 2, and 3 on your own. And when you're done, start the video and see how you did. Okay, so number 1, 3 times x minus 6 is greater than 9. I'm going to divide by 3, divide by 3. Absolute value of x minus 6 is greater than 3. Now, because this is isolated, I can say or. So that means this is going to be an or. So x minus 6 greater than 3. Here, x minus 6, change the direction, change the sign. This ends up being x is greater than 9 or x is less than 3. So when I graph this, classic or, less than 3, that direction, greater than 9, that direction. Okay, so that's number 1. Now number 2. The absolute value of 6x minus 11 less than or equal to 7 means 6x minus 11 less than or equal to 7 less than 6x minus 11. Flip the sign, make it negative. We get 6x is less than 18, x is less than or equal to 3, and 6x greater than or equal to 4. X greater than or equal to 2/3. Classic and, so it's in between 2/3 and 3. And it looks like your classic and. Okay. And then number 3, whoops. Number 3, negative 2, 6x minus 1 plus 5 less than 3. Negative 2, 6x minus 1. Subtract 5 from both sides, negative 2. divide both sides by -2. And remember, as soon as you divide by a negative, flip the sign. And this is greater than 1. So now, even though it looked like you were going to have an and inequality, you ended up with an or inequality because once you isolated the absolute value sign, it was or. So this becomes 6x plus 1 greater than 1, or 6x plus 1. Flip the sign, make it negative. 6x greater than 0, or x is greater than 0, or 6x less than -2, x is less than wait a minute, I copied this wrong. So for those of you who are astute enough to realize that should be a negative, sorry about that. So that's a negative. This is 6x is greater than 2. X is greater than 1/3. And this is minus, so that becomes 0. And this is x is less than 0. So sorry about that. The final answer is x is less than 0, or x is greater than 1/3, which basically includes most numbers. So less than 0 is that way, greater than 1/3 is that way. Okay, so sorry about that. I got that wrong at the beginning. X is greater than 1/3, or x is less than 0. Okay, so now we can fill in the bottom part of your notes. It says on page 34, one-step and multi-step inequalities. Follow the steps for solving an equation, but flip the inequality symbol when you multiply or divide by a negative. So you're going to write flip when you multiply or divide by negative. Okay. Compound inequalities. If necessary, rewrite the inequality as two separate inequalities, then solve each inequality separately. Include and or in the solution. And for absolute value inequalities, if necessary, isolate the absolute value expression on one side of the inequality. Rewrite the absolute value inequality as a compound inequality, and then solve. Okay, so that's the end of this lesson. And now you can follow the directions in Google Stream.